If this integral has the power series expansion this, then a5 is equal to what? Correct up to 3 decimal place. If anyhow we can find this integral, then this integral will come in the function of x, or we can write in function of x. If we could able to write this integral term wise in power expression of integral power of x, then we are very close to the power series expansion and we can easily find a5. Otherwise you can write this function, this integral, and try to find the terms a5, as this integral 0 to x e raised to the power minus t square plus cos t dt. You can consider this can be written as power series expansion. So a naught x, a naught plus a1 x plus a2 x square plus a3 x cube, or because this is starting from 0, so a naught x raised to the power 0, it is 1. Okay, this is fine, and so on. And now apply Leibniz rule for differentiability. So if you apply Leibniz rule, so e raised to the power minus x square plus cos x, this will be the result after applying the Leibniz rule, because of integration, sorry, differentiation of x is 1, means upper limit, differentiation of upper limit is 1, and differentiation of lower limit will be 0. So other term will be 0, and finally we have this. So in right hand side we will have a1 plus 2 times a2x plus 3 times a3x square, and so on. Now expand this by exponential function, means e raised to the power x, and we know that expansion of cos x. So expansion of e raised to the power x is 1 plus x square upon factorial 2 plus x cube upon factorial 3, and so on. And expansion of cos x is 1 minus x square upon factorial 2 plus x raised to the power 4 upon factorial 4 minus x raised to the power 6 upon 6 factorial, and so on. So put these value in left hand side and try to compare the coefficient of as we obtained from this. So this is one approach, or simple one is try to find this integral and write in terms of x. So what is this integral actually? So this is 0 to x e raised to the power minus t square plus cos t dt. So expand this one, we will have 1 minus t square plus t raised to the power 4 upon 4 factorial. Here also 2. There is no 2 because of factorial 1. This is, and this will be 2 factorial, and minus t raised to the power 6 upon 3 factorial, and so on. And expansion of cos t will be x minus there is no need to write expansion form of cos, because of we know the integral of cos directly, so there is no need to write. Otherwise you can use this expansion. So this is 0 to x, and this is 0 to x cos t dt. Now we have, after integration, t minus t cube upon 3 plus t raised to the power 5, and this is factorial 2. Also 5 2 is 10, minus t raised to the power 7 upon 42, and so on. And limit is, this is t also, limit is from 0 to x, and this will be sine x, because integration of cos t is sine t and t replaced by x. So this is, and we have to write this as in power series expansion, means integral power of x. So you need to write expansion of sine. Sine expansion is x minus x cube upon factorial 3 plus x raised to the power 5 upon factorial 5, and so on. And after replacing t by x, we will have x minus x cube upon 3 plus x raised to the power 5 upon 10, and so on. So we have to find a5. a5 is nothing but coefficient of x raised to the power 5. a5 is nothing but coefficient of x raised to the power 5. This is because all these terms are positive or negative. So coefficient of x raised to the power 5 will be 1 upon 10, plus from this point we will have 1 upon 5 factorial. Solve this expression. 1 upon 10 plus 5 factorial is 1 upon 5 4 is 20. So 120, and this is equal to 13 upon 120. And because this question asked in exam, so there will be scientific calculator in your exam portal, so you can easily calculate what will be the decimal expansion of this one, as I have calculated using another device. So this is equal to or approximately coming this one. So 0.108 will be correct answer, means value of a5 is equal to 0.108.